Hey, good morning, class. Today we're starting our chapter on probability. You'll notice there's no SS there, which means to say that it's not examples only. It's going to be the extension or the full lesson, basically, is going to be recorded here. Also, last year I didn't do the recording for some reason or other. But this year, so in this series of videos, we're going to look at the questions, and we're going to look at firstly the previous day's homework will also be marked on here, as well as the questions itself, the examples. Okay. So let's go. So we got the probability before. Okay. We've done probability in grade 8 and grade 9. Okay, so you are familiar with probability already. So just to refresh your memory, what probability is all about. We're just going to name a couple of things here. So we're reading from page 375. Examples of on page 375. However, the exercise 17.1 is on page 378. 78. All right. Let's go. Outcomes and events. So to say, refresh it quickly. In a coin is tossed, there are two possible outcomes. It can either be a heads or a tails. So that are your outcomes. In South Africa, the word dice. In South Africa, the word dice instead of die is commonly used for the singular. We say that's a dice, not so. It's actually called a die. Now we people that's scared of the death, not so of the dead. So what we do, we rather call it a dice. Okay, because we're busy with that 15 times when we're busy with the die. No? So it's basically one die, many dice. No? When a dice is thrown, there are 6 possible outcomes. It's either a 1, a 2, a 3, a 4, a 5, or a 6. In an event, consists of the outcomes you are interested in. For example, getting an even number when rolling a dice, which is 2, 4, or 6. Okay. Yes? Sorry? You got the question? Compound events. So compound events, it's more than one event happening at the same time. Okay? So you can be tossing a coin or rolling a die. Or you can be tossing a coin twice. So you can be rolling 2 dice. So you can, many scenarios. You can be throwing a card and rolling a die. Could be many things. So compound is more than one thing happening at the same time. So let's say you read what they say here. Compound events. When a coin is flipped and a dice is rolled at the same time, a compound event occurs. The possible outcomes for this activity are listed in the table. Okay, so one way we have the die outcome going in that direction with the dice outcome and the coin outcome. So remember, for a dice, it can be either a 1, a 2, 3, 4, 5, or 6. Hence these numbers here. Okay, and a coin can either be heads or tails. So if you roll a 1 and flip a heads, it's H1, heads 1. Can you see that? If you roll a 4 and you roll a tail and you flip a tails, it will be tails 4, and so on and so on. Okay, so the table helps us to list all the events that can occur. You guys understand? What's wrong, Nisikanya? You smiling? You laughing? Are you okay? Are you okay? You sure? First time I see you smile and now you're laughing? Alright. For an event, a hit and an even number, the favorable outcomes are H2 or H4 or H6. So a hit People, heads and even numbers. Those are even numbers. So we do the overlap. H6, H4, H2. Are you all okay with that? Okay, those are the favorable outcomes. Now remember last year when we worked out our probability, what did we say? To calculate probability of an event, use the formula. The probability is equal to the number of favorable outcomes over the number of possible outcomes. So if we take this example to work out the probability of it being a heads and an even number, the probability is equal to the probability of your favorable outcomes or your probability of possible outcomes. So how many outcomes are favorable here? 3. Can you see that? For the condition, in other words. So it's 3 out of how many outcomes are there in total? 6, 12. 12. Not so? Why 12? Because there is 12 in total. The possible outcomes. And 6, 3 over 12 is? 1 over 2. Okay. Always simplify your probability. Okay. You can either write it as a quarter or 0.4. So you say 3 over 12. The quarter or is a standard decimal. 0.25 or percentage as 25%. Any one of those will be acceptable. They won't tell you to write it as a percentage or a fraction or a decimal. You have a choice here. Okay, you can write it in your favorite format of a number. Okay. Right, 3 diagrams. We spoke about 3 diagrams last year as well. Correct? So note the probability on the branches coming from any one split in a tree must add up to 1. What are they referring to there? Before we read what they're saying about the 3 diagram here, what they're referring to here is that here it splits from that point. What is a half plus half? 1. There's a split coming there. Can you see that? What's a half plus half? There's a split. Half plus half? 1. So from where it splits, those branches always adds up to 1 from that point that it splits from. You all okay with that? So let me know when I'm moving too slow, né? I know you guys want to get into this calculations. Okay. The compound event of flipping 2 coins are represented using a 3 diagram. Alright. So let's just ignore this quickly. If I flip a coin, and I flip it twice, né? In the first flip, what are my outcomes? It can either be a heads or tails. So it's heads or tails. H or T. If I flip, what's the chance of me flipping a heads? 50%, which is 1 out of 2. So it's 1 out of 2. And the tails? 1 out of 2. Can you see that, people? So if I flip heads first, what's the chance? What are my outcomes on the second flip? Heads or tails again, which is half. If I flip tails, again heads or tails. Can you see that, people? Again half and then half. You see this here is your first flip, your first toss, and that is your second toss. People, you guys understand? Which that you have there. Okay. So this is toss 1, and that is toss 2. Okay, you guys understand? So if they ask you, what is the chances of flipping the probability of hitting a heads followed by a tails? Heads first, then tails. And what will it be? Heads. So half times half, which is a quarter. But if you look at it, what's my outcomes here? It can be heads, 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 tails, tails, heads, tails, tails. And this is first heads, then tails. Then will be 1 out of 4. Can you see that? You only have 1 out of 4 chance there. Do you guys understand? Otherwise, if the question is, what's the probability of doing a heads or tails in any order? Heads or tails or heads? Will be half. Why? So it will be a quarter plus a quarter. Does that make sense? Which is half. 2 heads, a quarter, and so on. Okay. So this is what they are saying here. Yes? Shall we? This. It's better not to move it, okay? Huh? The more you move will be better. There's a seat, there's a seat, there's a seat, there's a seat. There's a seat, there's a seat. Alright, so the tree diagram, the compound events of flipping 2 coins are represented using a tree diagram. The probability of heads or heads is half times half, which is a quarter, heads, tails. So half times half, which is a quarter, tails, heads, and tails, tails. Okay, if we add this 4 quarters up, what are you going to get? 1. The probability will always give you 1. Okay, let's carry on. Note. A pack of playing cards. So let's go into playing cards quickly. Just remind you quickly, for those of you who never played cards before. Right? Right. You get 4 different suits. Not so. What are the suits? Clothes, yes. Right, so you got clothes. So in the clothes, people settle down. In the clothes set, or clubs, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and Ace. Now some would write the Ace in front of the 2. Not so. Then they count Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. Not so. So how many clothes cards are there, or clubs? There are 13 in total. Not so. So give me another spades. Right. Spades again, you're going to get 2, 3, 4, 5, 6, 7, 8 of spades, 9, 10, Jack, Queen, King, and Ace of spades. Okay, you will agree with that. And this is called the blank suits. Not so. Right. Then we get the red suits. Which are? Hearts, yes. We are hearing somebody saying hearts from the beginning. We know somebody in love. Yes. They go 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, King, Ace. Again, there are 13 hearts cards. Not so. Then you have Diamante, diamonds. 2, 3, my favorite. 3, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and Ace. People, there are 26 red cards. Not so. Okay, and then there are 26 black cards. How many cards are there in total so far? 52. 13 times 4. 52 cards in total. Okay, so people listen. When we open a pack of cards, for those of you who opened a fresh pack of cards, a brand new pack, no? It feels the best. No? It's not being touched or used. No? So what happens is, you open a pack of bicycle cards. In that, you're going to get 2 jokers. Right? Maths is not about jokes, so we take them out. We're not interested in those 2 cards. Okay? If we are busy with another subject, maybe we'll put them in. Okay? But maths, no time for jokes. We leave them out. So whenever they say, we are considering a pack of playing cards, they don't consider jokers. Okay? Some games you need the jokers, so like in sets and those things, whilst in others you don't. No? But anyway, we don't use that. Then you get a guarantee card. They say there's something wrong with this pack. Please send it with the guarantee card, plus your ace of spades, and your comment on what the issue is. They will gladly refund you and send you a new pack of playing cards. Okay? That's a guarantee card. 2 jokers, a guarantee card. Okay? Then there's a blank card with nothing on. Okay, for those of you who open the pack, you'll find the blank card. Okay. That's also not a part of this when they say pack of playing cards. And they have the, not calendar. It looks like a calendar, but it's actually poker rules. The poker rules is also in there. No? The rules of poker. So the 5 cards extra in this pack of playing cards is not considered. We're only looking at these 52 cards. Does it make sense? Now, I need to say this at this point as well. Some uses the ace as a picture card. So these are picture cards. Picture cards. Whilst other textbooks does not use the ace as a picture card. Okay. Now, in the exam, if it's a picture card, if ace is counted as a picture card, we will tell you it's a picture card. If ace in the exam is not supposed to be a picture card, they will tell you your picture cards are Jack, Queen, King. You understand? So it will be specified. However, if it's not specified, we will give you the marks either way. Okay, so don't call me, what is a ace, a picture? No. You answer it as if, whatever you think, if you think consider ace to be a picture card, you treat it as a picture. We must give you the marks accordingly. So as I said, some textbooks uses ace as picture cards, whilst the others doesn't. Okay, it makes sense. Alright. That's it. So a lot of things done, huh? Right, so let's look at the questions. So note, a pack of playing cards has 52 cards in it, excluding jokers. Divided into 4 suits of 13 cards each. In 2 of these suits, the cards are colored red, which is hearts and diamonds, and the cards are colored black, which is the clubs and spades. Okay. Now we are told these cards are from the suits of clubs. You see, there's the clubs, no? And you know, I'm sure all of you had some experience in playing the cards. Okay. Here, we are told that these are the picture cards of the suit of spades. Now you see, these are the picture cards. They shouldn't have put in the pen. Okay. But mistakes happens. Okay. So where's my marker now? They're right over it. There's it. Right, so which page are we on now? 76. What? 7. Now why didn't you tell me when we turn the page, we are on the next page now? People think there's something wrong with me. Okay, we know there's something wrong. Right. People, 377. Let's look at the example 1 here. We are told, okay, so first note. We will assume that all coins are fair coins, for which the probability of either a heads or tails is 0.5, which is 50-50. Okay. Why do you think they say it has to be fair? Why, you will always see that they will say that it's equally likely or whatever. Okay. Basically what happened a couple of years ago, okay, in cricket, you guys have watched cricket? No, okay. Let's use some other scenario. Okay, so if you take a die, no, a dice, one die, and we polish that dice, no, or we put on a little Vaseline on the one side of the dice, just one side, then the chances of it landing on a particular number is higher. It's cheating, yes. Okay. So what happens is, I don't know if you've seen on the movies where the robber with whoever the chase is running through the casino. No? And then there somewhere in the background you'll see there's a guy that is testing the dice. There's a machine, then they spin the dice. Now that is to check if the dice is fair. Okay, that has to be a fair dice. So what happens is, if you put Vaseline on one side of the dice, it's going to be weighted more somewhere. You understand? Which means to say it will most likely land on a particular number more times than others. You understand? So when they say it is a fair dice or it's equally likely or the odds are even, not the odds are even, but the chances of the landing on any number is equal. By saying that means to say that everything is fair. Also, when we go with this in a bag or marbles in a bag, we must consider that marbles all to be the same size. Why? Because if you put your hand into the bag, the chances of you throwing a bigger marble is larger. Not so? Likewise, we're putting tickets in a bag. A couple of years ago, we were at some function. So what they do is they come around, they take the stubs of your tickets, no? And then they put it in a jar. Right? So what happens is, sometime during the course of the function, they draw the number and they call you up and you win a prize. No? Right. So what happened is, there was this one table. They're doing this for years already. So what they did was, they know already what is coming. There's going to be a draw. So what they do is they tear off half the ticket. From that 10 people, 6 people won prizes. Yeah, 10 people around the table. There was like 15 prizes or whatever. 6 people won prizes at that table. Why? Because the chance, the what's his name, wasn't fair. Okay, why? Because why? They threw off half the ticket. So the chances of them being drawn is much, much greater. You understand? So, take note of when they tell you it is a fair situation. Okay. So, the question says, what's the probability of? Right, what's happening here? What's the probability of getting a heads when flipping a coin? What's the probability of getting a heads when flipping a coin? Probability of getting a heads, number of favorable outcomes over number of possible outcomes, which is 1 over 2. So let's look at B. Getting a multiple of 3 when rolling a dice. So the number in stand for number, the number of favorable outcomes. What are favorable outcomes for even numbers on a die? 2, 4, 6, 8. No, 8 is not on the die, no? No. So 2, 4, 6. There's going to be 3 out of 6, which is getting a head and a multiple of 3 when flipping a coin and rolling a die. Getting a head. What's the head? Sorry, this is C, no? So it's going to be, this is number. The number of even numbers is 3. So the probability is going to be 3 out of 6, which is all. Yes? Yeah? Sorry, my mistake. I'm reading did I say multiple of 3? But I'm looking for even numbers. Something wrong with me? I think we are getting confused is they say the probability, the number of favorable outcomes is marked with P even. Or N even, sorry. NE, that is the number of favorable, that's marked by the number of favorable outcomes. And NS is number of the sample space. Okay. So again, let's go. Let's list the multiples of 3. 3 and 6. Which is 2. So the probability is simply 2 out of 6, which is 3. Thank you for that. People getting a hit and a multiple of 3. So the probability of a hit times the probability of a multiple of 3. So that would simply be a half times a third, which is 1 out of 6. Okay. You guys understand? Now, there's many ways of doing that. I could have done it like that, or I could have drawn a 3 diagram. Okay? Let's draw a 3 diagram. For those of you who don't see who don't relate to what they just did there now, what I just did there. So, for a tree diagram, you can either go with flipping the coin first or rolling the die. It doesn't matter. Okay. So for flipping the coin, what are my outcomes? It can either be heads or tails. So what are the waiting on the branches? Half. No. Half plus half is 1. Now if you throw a heads first, okay, multiples of 3, let's call multiples of 3, is going to be 3 and 6. How many multiples do we have? 2 out of 6. Multiple of not 3, that is everything else. You see the thing on top means not. Okay? So how many not 3s are there? 4. So what's the probability? 4 out of 6. A multiple of 3, 2 over 6. Multiple of not 3, 4 over 6. So let's go again to the question. The question says, getting a heads and a multiple of 3. So in other words, it must be a heads and a multiple of 3. I think later on they will explain the intersection. Okay. Don't worry about that for now. So it's a heads. So it's a heads. And it's a multiple of 3. Can you see that, people? So let's go. Heads. And what's the probability of heads? Half times the multiple of 3 is 2 out of 6. If you work that out, I get 1 out of 6. This is the same. You guys understand? That's another way of looking at it. Otherwise, we could have drawn a table. Yes? Yes? You can simplify to 1 over 3, but we tend to leave it like that. Why? Because when we work out the other branch, it's basically the other number. Okay? So you can, but you'll normally find it in that format. Okay? People, if you draw on the table, look at the table. Remember on the table, it's going to be, I think that there's a table drawn already, no? Okay, let's just do it. Okay, so it's, what are the outcomes? It's the die, no? So the options on the die is 1, 2, 3, 4, 5, and 6. Not so. The coin, heads and tails. So it's going to be heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. Tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. So we're looking for the probability of getting a heads, and a multiple of 3. So now let's see. Heads, multiples of 3 is that one and this one, not so. So it's how many? 2. 2 out of how many in total? 12. And 2 out of 12 is 6. 3 different ways, people, to do the same thing. You guys understand? Who still don't understand? Alright, you all understand. Which way do you think is the easiest of the 3? The first one, okay. I say all is easy. Huh? Yes? If they ask you to draw a table, it's probably 3 marks. With the probability, another 2. So it's 5. Okay. People, let's look at this quickly. Here we are told, what's the probability of drawing a picture card from a pack of cards? A picture card. Did they specify the suit? No. So it can be picture cards of any of the suits. Not so. So let's go up again. Okay. Just copy. Right. Whoops. Gonna make it smaller? No. Okay. So the question says, what's the probability of drawing a picture card? So the picture card are 4 per suit and 4 suits. So how many cards are there in total? 16. Not so. So A. What's the probability of drawing a picture card on a pack of cards? It's going to be 16 out of 52, which is 4 over 30. You guys understand? Let's look at B. What is the probability of drawing 2 consecutive cards if the first card is drawn, or the first card drawn is not replaced from the second? Okay, so basically, that you. Let's make our own one, our own sum first. Okay, we're gonna come now back to this. So I don't want you to get confused now. Okay, let's say, oops, that's not B. This is our own sum now. Let's say, what is the probability of drawing 2 cards, not consecutive cards? Yeah, okay, 2 consecutive cards, picture cards, if the first card drawn is replaced? So I'm going to say, in this example, is replaced. Okay. So, looking at this quickly. So, if I draw a H, the uncle. You see the uncle busy with this meeting. Right. People listen. Relax your bones. Right. What's the chance? If you're looking at picture cards and non-picture cards. Okay. So, what is the probability of drawing a picture card? 16 out of over 52. And non-picture cards? It's the balance thereof. So 52 minus 16 is 36. That's going to be 36 out of 50. Now, if that card is replaced, which means to say it is put back into the deck of cards, on the pack of cards, shuffled again, then what is the chances of me drawing a picture card on the second draw? 16 out of 52. And on picture, 36 out of 52. Not so. Now, if you draw a non-picture card on your first draw, then what is your chance of you drawing a picture card on your second draw? 16 out of 52. And non-picture, 36 out of 52. Now going back to the question, what's the probability of drawing 2 consecutive picture cards? If the card is replaced, so this is the probability of a picture, and a picture again. Okay, 2 picture cards. So in other words, I must follow this branch. Not so. And then the top branch again, because those are the 2 picture cards. Not so. So that would simply be 16 out of 52 times 16 out of 52, which is 16 out of 169. 16 out of 52 times 16 out of 52. 16 out of 169. Can you see that, people? We convert that to decimal 0.094 or 9.4 or 9.5%. You guys understand? So let's go to 16 out of 169. Let's go to the question itself. The question says, however, the card is not being replaced. Okay. So let's look at that scenario. That was now B. So, if I shuffle the deck of cards, what's the chance of me drawing a picture card on the first draw? 16 out of 52. A non-picture? 36 out of 52. Now, if I draw a picture card on my first draw, however, the card is not being replaced.
15 over 51.
Then you copy it out on the test. Okay, now joke. Now just make a joke, man, relax. So 15 out of 51. Says here. How you get that? Explain to them.
Because there's 16 picture cards, you take one out, you didn't put it back. So that's 15.
So there is 15 picture cards left. Can you see that? Out of how many cards? 51. Because you got one card less now. You understand? But how many non-picture cards do you have? Still 36. 36, and how many cards are in the deck? 51. Right. So let's look at the other scenario. We shuffle the deck. The first card is a non-picture card. First card in the draw is a non-picture. So how many picture cards are there? 16 out of 51. And how many non-picture cards are there? 35 over? Any book, guys? Yes, Anna. Right. So let's look at this probability. So before we do this calculation, do you think that probability is going to be higher or lower than this? You want to be lower? Why lower? Huh? If you look at the fact that I have in my second draw, if I'm looking at the probability of two picture cards, okay? If you're looking at 16 out of 52, and the other one was 15 out of 51, which fraction is larger? You sure? 15 out of 51? It's going to be 0.29, 16 out of 52, 0.3. So 16 over 52 is larger, not so, which means to say this has to be a higher probability. Okay, but let's see. You are right. So the probability of drawing a picture card, let's see. Which path would we follow? 16 out of 52 times 15 over 51. Yes, Michael. I thought you were going to ask me something mathematically now. Times only mathematical. Go, my God. So you get 16 out of 52 times 15 over 51. So let's put that in the calculator. 16 out of 52 times 15 out of 51. That gives you 0.0904, which is 20 over 221. Which confirms what we are saying. Everybody guys understand? Is there any confusion? No. Okay. So for homework, is the exercise? Who's taking my homework? At this one. Right? Exercise 17.1, you do for me number 1. Number 3. 5. 6. Not 7. And now 7. Okay. You guys understand? There's number 1, 3, 5, 6, and 7. The reason why I put 6 in because 7 was dependent on 6. Okay. Let's carry on. How much time do we have left? 30, okay. Exercise 2 is on page. Sorry? 2? Exercise 17.2. 381. Okay. In our next lesson, we will mark those questions. Okay. So sample space, we're reading from page. Sample on page 318. 80. Okay. Sample space. Okay. So sample space. Take the 4 cards of the suits of hearts from a pack of cards. So take the 4 cards of the suit of hearts from a pack of cards. Consider these cards as the only cards to choose from in order to describe events. Take 4 cards of the suit of. Okay, so you can take any 4. Okay? Why didn't they say take the 4 picture cards? I think that is what they wanted to say. Because if they would take any 4, I don't think they would have taken Ace, Jack, Queen, King. It would have been any of the 13 cards. Can you see that? But I think that it would be fair to specify, take the 4 picture cards of the suit of hearts from a pack of cards. Okay, so in other words, we got the ace from hearts, we got Jack, Queen, King, and Ace. So it's 4 cards there. Okay. Consider these cards as the only cards to choose from in order to describe events. The set Ace, King, Queen, Jack is known as the sample space for the event. A Venn diagram. Have we done Venn diagrams before? Slow. Okay, so that's why we need to move a bit slower now. Okay. A Venn diagram is a diagram that is used. The Venn diagram is a diagram that uses an enclosed area to represent a set by writing the elements of the set in it. Okay? To represent a sample space, Ace, King, Queen, Jack, using a Venn diagram. So this is basically what it looks like. Okay, that is your sample space. Some of you are confused. So let's take it one step back. Okay? If I must now write the sample space for rolling a die. Okay, what are my outcomes? It's going to be 1, 2, 3, 4, 5, 6. Okay. If I must write this as a sample space, the S was your sample space now. If I write S as a sample space, and I'll put the S there, and I'll put 1, 2, 3, 4, 5, 6. Or I could have put that 6 up here. Whoops, not. The 6 don't have, the 5 don't have to be there. The 5 could have been here, and so on and so on. You guys understand? That is your sample space. Still confused? Let's look at tossing a coin. What will the sample space be there? Heads or tails? Here's my sample space. Heads or? These are called elements in the sample space. Elements, okay? I think they will mention that later. But you all understand how the sample space works. It's whatever the options are. the number of possible outcomes the elements are listed. Okay, that's all. Come on. So let's carry on. The Venn diagram is a diagram that uses an enclosed area to represent a set by writing the elements of the set in it. To represent the sample space of ace, king, queen, jack, using the Venn diagram, the sample space is simply ace, king, queen, jack. Can you see that? Again, they put the thing in by mistake here. Okay. Probably realized it, but you don't want to now retake the picture. Okay? So they didn't see. Okay? I think they didn't see. Okay. The set of outcomes or sample space are also referred to as the probability space. Okay. The sample space associated with statistical experiment in the set of all possible outcomes of the experiment. Okay. Right, let's carry on. Let's look at an example now. Okay. This example is on page 380. Still on page 3. Right. So, the ace, king, queen, jack are not involved. There is no number cards for number 1. The ace, king, queen, jack are not involved. There is no numbered cards for, okay? I don't know what they mean there, but okay. Let's look at number 6. Yes, I'm missing some. The picture card, they also told us that the picture card is also known as space cards. Okay? Ace, jack, queen, king are not involved. There is no number card for the number 1. They're just telling you that there's no number card for number 1. Okay, now some people put the ace as the first card. And then they don't consider ace to be a picture card in their probability calculations. Again, as I said at the beginning of the lesson, if they want you to calculate your ace as a picture card, they will say. Or if they want you to exclude it from the picture set, they would say. Okay? So now next year we're going to use different textbook and they exclude ace from the picture set. Okay, but I will just remind you at that time again. For the 5 of you that's going to do maths next year. Yeah? Only a check. No? This topic is giving you guys hope. No, you can do maths. You said no, but your algebra is fine. So, that's all right. The numbered cards from the suit of hearts are is placed in a hat and then shaken. One card is drawn out at a time and then replaced. So it's put in back. No? Right. So let's list what we have here. So what is the sample space consist of? A number card is taken from the suit of hearts. So what are my options? You just told you now there's no 1 of hearts. 2 of hearts, 3 of hearts, 4 of hearts, 5 of hearts, 6, 7, 8, 9, and 10 of hearts. So how many cards are there? 9 cards. 1, 2, 3, 4, 5, 6, 7, 8, 9 cards. Okay. So we are told 1 card is drawn out at a time and then replaced. A. Give the example of an outcome. An example of an outcome. It can be any one of those cards. No? So let's go with the 5 of hearts. Okay. A sample is any element from that. You're going to say 5 of hearts. You're going to say 10 of hearts. You're going to say 2 of hearts. Could I have said 2 of hearts and 4 of hearts? No. They want 1. You guys understand? Yes. But any one of it you could have chosen. Okay. Let's look at B. B says list the elements of the sample space. That's exactly what I did here. Not so. So there's my sample space. Okay, you guys understand? Is there any questions so far? No. Yes, Michael.
So,
yes.
Don't you say 5 or 9?
Sorry?
Hey, so did you say 5 to 9?
Hey, give an example of an outcome. Did they ask you the probability of having a one out of the sample space? They ask you probability, then it's 1 out of 9. Do you understand? But because it's not specified in probability, so you don't do the calculation. Then in C it says represent a sample space using a Venn diagram. So what will this be? Will be S, and here goes 2, 3, 4, 5, 6, 7, 8, 10. This is my sample space. People, you guys understand? Homework. Homework is listen. Exercise 17.2. Number 1, 3, 5. Yeah. Tomorrow we'll talk about events. People, enjoy the rest of your day. Good afternoon, class.